Hello guys, welcome to Talent 500 YouTube channel. This is Himanshu Gupta, a software developer and a tech educator. So today's video is the continuation of our series on REST API interview questions, which is going to be very helpful for all the folks preparing for backend development interviews. So stay tuned and let's get started. First of all, we'll discuss what is the agenda for today. So today we are going to focus on how to design a URL for a REST API. So as we discussed earlier in our previous video, that REST APIs revolves all around URLs, and URLs are very basic building block when you try to define the contract of a REST API. So we will today discuss that how to design a good URL for REST API and how a bad URL design might look like. Then we will see what are query parameters in REST APIs and or basically the URLs, and when to use them and when not to use them. Moving forward, we'll discuss what are the HTTP status codes in REST API and what do they mean and what do they define, and then we'll discuss some other concepts about designing REST APIs is what are HTTP headers and how they are used in the context of REST API. After that, we will also discuss how to handle errors and exceptions in REST API. And in the last, we'll give a e-commerce example for a REST API design, like how a REST API design might look like for an e-commerce platform. Okay, so let's get started. So in this slide, we'll discuss about how to design a URL for a REST API. So URL design in REST API is very much indicates that how the other partners or the consumers of your API will understand about your API. So as URLs needs to be very clear, very consistent. So what are some of the best practices when you go about designing a URL? So first of all is use of nouns to represent your resources, and try to avoid verbs and actions. Let's say you have an e-commerce website, and okay, you are designing a URL for orders. So if you want to get orders, your URL should look like orders and do a get on that. Okay, so orders here is a noun, so you should always use nouns while designing your URLs. Use a hierarchical structure. So the second point, it's also very important because the relation between your entities or the resources should be very well mapped in your URL design also. What do you mean by that? Let's say on the same e-commerce platform you have a user, and the user will have orders. Okay, so how that particular URL design should look like? It should be hierarchical in the sense that let's say if there are users on my website, okay, this first my URL says okay, I have users, and then for them the orders are there. So this becomes the hierarchy. Users have orders, and here could be an order ID. Okay, so this becomes an example of a hierarchical design of a URL. So this is basically to reflect the relationship between these two entities. So the third point is use plural nouns for collections. So in an e-commerce website, let's say you will always have many users. No, you won't have only a single user. So slash users means that you are using a plural noun, not you are not using slash user and then user ID. This basically tries to convey that you have only a single user. You can use that still, but it is a best practice to use a plural for when there are a good number of entities for that thing in the system. Basically, it is a collection. And then for users, you have orders, and orders can also be multiple. It will be a collection for a user, right? A user over a period of time can have multiple orders. So and this again becomes an example of how for a collection you use plurals. You can think of other examples also where you don't need plurals. Let's say for a user, what can be a single thing? A cart. Okay, so in for a user there will be only one shopping cart at all the time. There won't be any 10 shopping carts for a user in an e-commerce website, right? So if you want to show that, then that entity will look something like user ID. I am not writing that, then it can be a cart. Okay, so this is the kind of URL we will try to define for that. Then use HTTP methods to indicate actions. Okay, so this is very important, that sometimes what while designing REST APIs, what you people try to do is they try to define in the URLs what they are also doing. That is not required. In the URLs, it should only be defined that on what entity this operation is going to be done, and what you are going to be done should be very well described by our HTTP methods, like as we discussed in our previous lecture site, get, put, post. So all these actions very well define that what you are gonna do, because on any resource what you are gonna do, you are gonna do any of the CRUD operations, right? You are gonna do create or delete or update or something like that. Okay, so HTTP methods are very well equipped in every sense to basically tell what action you are going to do on the resource. So never include the action part in the HTTP URL, but use HTTP methods for that. So the last point here is keep URLs very simple and easy to read. This should be like whenever you are programming, it should be always true, like your variable's name in the program should be very clear and intuitive, and simply as this URL should be more intuitive in that sense, because it is being exposed for n number of parties to be used, right? So or like say users is a very intuitive form of a URL, and for this bad URL design would be users of this website. Okay, so you could have also used this. There is no boundary of what you can use. Users of this website you could have written here, and then user ID. Okay, so you can do that, but it is not a good practice. Keep your URL simple and easy to read. Okay, so let's now try to understand what is a good versus a bad URL design with the help of an example. It is basically based on all the best practices which we have just discussed in the previous slide. So let's say you want to get the list of products in your entire inventory, right? So for that you use the HTTP method of get, and you use /products/product ID as the URL to get all the products in your inventory. And other form of URL design could be you do get of your and then you say get product, and then as a query parameter you pass the ID of the product which you want to get. So what are the differences, or what are the best practices which are not followed here but which are followed here? So this will try to discuss. So first of all, the products, it is a noun. So get product, it is trying to basically define the action which we are trying to do. Okay, so this is not what we want to do. This is a verb, this is a noun. So the second thing is here products, it is a collection, so it is also plural. Here we are trying to define get product as a single action plus a single resource. So the third thing, the architecture of this, basically the URL design is hierarchical. So we want to get products, and then we tell this is the product ID. But here we have the ID, we are trying to give it in a query parameter. We will discuss what are these query parameters, but for now you can just understand that this is a query parameter which we are giving to this URL. But here in the URL itself we are defining product ID as a hierarchical thing. So in these two examples you can see how a good versus a bad URL design might look like. So guys, next we will discuss about query parameters. So query parameters are generally used for on a collection of resources when you are trying to do some operation on a collection of a resource. So, and you want to provide some additional information which you cannot either fit in the URL or in the request body also. An e-commerce platform has thousands of resources, and you want to get all these products, but you want to filter these products based on something, let's say price. So how do you do that? You will do a get of products, and now you will provide some extra query parameters. Let's say products question mark price, and you say 50 to 100. So now decoding this is the job of the server. Server already must have defined this in the construct that these are all the query parameters which I accept for these for this collection, and you're going to use any one of them. Otherwise, server will throw you some error that I do not understand this, right? So here what we are trying to do, we are trying to get all the products, but we are trying to put a filter of price on that price for 50 to 100 only. So this will give us a filtered result of all the products which we want to get. Other than that, some other operations can be sorting or pagination. So what does sorting means? It is very simple. Get of products you want to do, but you want to sort the list which it's returned of all the products. A list will return, right? So you want to sort that list based on what? Let's say price. So now the result which is returned to you, it will first, let's say, fetch the list of products from the DB and then sort them also and give you a sorted list. In the default could be descending or ascending, and you might want to provide extra information. The order is descending, let's say. So this could also be another parameter. Okay, so the next thing is pagination. So as there are like thousands of inventory resources in a e-commerce website, right? But you don't want to show the entire resource list to the user in the first go. You first want to show the few resources, and if users have scrolled through all those resources, you want to show the next set of resources. So for that we use pagination. So for that also you use query parameters, and here you can use two generally used parameters, that is top and offset. So offset here means that you start from the 0th offset and give me top 50 elements. Okay, so if you want next 50, then you will say offset 1 give me 50 elements, and if you say offset 2 give me from 100 to 150 these elements. So this is how you use pagination, and you use query parameters to manipulate your collection of resources. Okay, but an interesting question arises after this is that will you always use query parameters in collections of resources only and never on single resource? The answer for this is no. On single resources also we use query parameters. And when do we use that? When there is some extra information which we want to provide to the server, but it cannot be present either in the URL or in the payload. Let's say you wanted to delete a user, but in this soft manner where user can basically recover the account in the next 30 days, right? So if I write it down, I will write it down something like this. You want to do a delete of users with this user ID. Okay, you want to do a soft delete. Okay, so now this is how individual resources can also utilize query parameters. So next we are going to learn what are HTTP status codes in a RESTful API. So till now, as we have learned, right, that RESTful API is basically standardizing the communication between applications, right? So when you are trying to standardize that, till now what we have learned is how one application is sending request and how that is standardized. Let's say we learned about HTTP methods, query parameters, and URL and payload. All this was how a request is sent to one application, but receiving responses is also standardized in REST API with the help of HTTP status codes. So HTTP status codes are generally 3-digit codes which basically indicate you that what is the status of the request which you have sent to the application. These 5 categories of HTTP status codes, starting with 1, basically 100 to 199, then 200 to 299, like this, right? So 1xx are informational status codes. So the server indicates to the client that, okay, I have received your request and I am processing it, and I am just letting you know that I am doing what was intended by you. Okay, so in this sense, an information is transferred to the client. Okay, so the classic example for 1xx is when you are trying to do a handshake process for a WebSocket connection. So for that, the HTTP status code it uses is 101. So when a client tells the server to use it now WebSocket connection, so in that process, the server generally responds with 101, so, which means switching protocol. It indicates that indicates to the to this client that the server is switching the protocol to web socket protocol. Okay, so the next category is 2xs, which means success. So success, so you will say that, okay, it means success, then why do you need 2xs? Only you can keep only 200, and then you can work only with that. But this is not the case, because when you try to send a do an operation, okay, let's say for products, you are trying to get products, or you are trying to edit products, or you want to delete products and stuff like this, right? So there could be different stages in which your operation might be. So when you do, let's say, get product, at that time generally you get a status code of 200, okay. But so when you're trying to create a resource, so server doesn't returns you 200, but it returns you 201, which means created. So this is all standardized to make applications understand, when I want to get a resource, I will get a 200 okay status code, but when I want to create a resource, I will get a 201. So if this is standardized, any thing which differs from the expected one, you can see understand that some problem is going on with this entire thing, right? Your entire setup or your application, how they are communicating. Then there is 202, which means accepted. So it is not always that whatever operation you are trying to do, it will just complete in a blink of an eye, right? Sometimes there are these long running operations which we call, which take time. So at that time, what server does is it returns you to not to accepted, that I have accepted your request, and will give you, let's say, some other URL where you can track your operation. But currently it is in accepted state. It will take some time for the server to create that resource. So then there is a third type of status codes, which is 3xx. These are redirection status codes. So redirection status codes are 301. 301 means moved permanently, okay, and 302 means found but is moved temporarily to different URL. So it is basically as per use. When you will use 301 or 302, 302 is found and 301 is moved permanently. So then after that, some interesting HTTP status codes are 4xx and 5xx. So 4xx means client errors and 5xx means server errors. So in any case, if server you send a request to the server, okay, and server detects that there is some error in the request which client has sent to me. So at that time, the server indicates that everything is working fine at my side, but something is wrong with your request, and here is the status code 400 bad request basically. So yeah, so here there are then multiple examples again, but in this case 400 client is this is a client error, and it means bad request. So the request which is sent to me, it is bad. Similarly, there are other error codes also, where like 401, 403, where 401 means unauthorized, okay, and 403 means forbidden. They are both of them are confusing, but I will try to explain in simple terms how what do they mean. 403 forbidden means the server is trying to tell that I understand the request. I also understand that this is a user in the system, but this user is not authorized to access this particular resource. Okay, a user might trying to access a resource, logged in user, which is basically not which does not have permission to access that resource. At that time we will use 403 forbidden, but 401 unauthorized we will use when the server tries to tell that I do not understand the request, which means that I do not uh, find you as a user. Okay, you are not logged in basically, so you are not sending a token which is valid, which the server can validate and see that you are a valid user in the system. So at that time the server tells that okay, this is an unauthorized user and I will send a 401. So if you see, all these three are client errors. Why are they client errors? Because something which was not done correctly by the client. The fifth kind of status codes are 5xs, which are server errors. So what server errors means that there is a very good terminology which is used in software development, right? That code fat gaya. So whenever this server side code there comes some error in that because of the request, then you return a 5xx type of error code saying that some error has occurred on the server side. It has nothing to do with your request. Your request was correct as per the current knowledge, but something has gone bad in the server. So please retry your request. So if some general error codes in 5xx are 500, which means internal server error. Internal server error. It means that we don't know something what has gone bad, but something has gone bad while processing your request. So please retry. Okay, generally 5xx error codes are retryable. Otherwise, one is 503, which means service unavailable. So one general example of this is when the service is overloaded and it is not able to uh, cater to your request. Okay, you have sent a request, but there are many other users also which are sending the request at the same time, and currently the service is not able to accept your request and cater to it, so it is returning 503 service unavailable. It is again a retryable error. You can wait for some time and retry the operation, and if the server is now free, it can cater to your request. So these are the 5 kinds of HTTP status codes. So next we will understand what is HTTP headers in the context of REST API. So HTTP headers are the pieces of metadata that are included with HTTP request or response. Okay, so this is extra information, additional information which is sent along with the request or received along with the response, and can include different type of information. What all information it generally includes? First is content type. So content type basically tells that the request which I have sent you, what type of content is there in the request. So it could be application XML, it could be JSON. Okay, so for JSON the content type generally is application JSON. So this is standardized. Okay, so the next thing is authorization. So when you send client server request, right, so you need to authorize your request also. So for that you need to give an auth token or an API key which basically authenticates or your request, and server knows that okay, this is a valid user making these requests, right. Then there is accept is the counterpart of content type, where you tell this client tells that in what form I accept the response. So it could be that some API tells that I can send you response in 10 different formats. You tell me whatever format you want, I will send you the response in the same format only. So in that case you can use accept header. After that, the fourth is cache control. So sometimes the response which you are trying to get from the server. If that can be cached, this cache control header can tell you information about, okay, for how long you can cache this information, and if you can cache this information or not also. So this another HTTP header which is used is e-tag. E-tag means entity tag. It is basically the current version of the resource which it has returned to you. Okay, so a user, so a resource might get continuously updated in the DB. So what this e-tag tells is the current state of this resource, let's say, is 21 in the system. So whenever a new update happens, the state will change to 22, or new update happens, it will change to 23. This is, I am using incremental numbers, but this, it doesn't always need to be like that. So next, what we are trying to understand is how do you handle errors and exceptions in your REST API. Okay, so handling errors and exceptions is very important in REST API, because what you want to communicate with the client is you always want to give them a clear direction about what has happened to their request. Either it has failed, it has passed, or whatever the state is, you want to very distinctively tell them to the user. And in case, like in case of 5xx site, as we discussed, there has some server error or something in the code has gone wrong. So at that time, it shouldn't be the case that some junk value is getting shown to the user because of our code which behaved badly. So the foremost thing is, whenever you are writing a REST API, you implement your exception handling. So all the exception code paths, you should handle that, and you should understand what exception has occurred, or if you don't understand that, just return a 500 internal server error. Okay, 500 error code to the user. Don't for the user, do not send them the exception, the entire payload. These are some cryptic message which comes because of your exception in the code, right? So do not do that. So exception handling. Then after that, use HTTP status codes. That is a must, because at any time any kind of error or exception is occurring in your system, you should try to understand what kind of exception has occurred. So let's say if a null pointer exception has occurred for some request, so then you will say 500 internal server error. But let's say when you received a request, you had to make another request for that. Okay, and now that request when you made, you have received 503 service unavailable, because you obviously made this request to some other server, or let's say to database also, and then database returned you 503. So then in that case, what you will do is, okay, you will handle that particular error in your DB, and to user you will return 503, that service is unavailable. Because for user, only your service matters, because your dependent service is not available. Now you are also not available for them. Okay, so you will say 503 service unavailable. So the next point to take into consideration is define your error contract and send meaningful error message to the user. Okay, so so HTTP status codes are good. The client application can understand that, but if client application has now to show something to the user, let's say that error has occurred, but if error is of the kind, if user had, you would have given some information to the user regarding the error, then user could have fixed it. Okay, let's say user has sent some bad request and it has received 400 bad requests from you, but if you are not telling the user that why this request is bad, okay, then how the user will fix it? So what we do when we have errors is, like, we define an error contract and we share it with our partners that this is the error contract, and in case any exception occurs in a system, you will get the details about that error in this kind of payload. You decode that, basically deserialize that, and then show it to the user or consume it for your purposes. Okay, So it could be it is something like this error. Now this has a code and there has a message. So for a message and so this code is now different from HTTP status code. HTTP status codes are a standard code and this code is some human readable form. It could be some human readable form, not necessarily, but it could tell that for 400 byte request you could have an error code, let's say param not set or param null, that some parameter was required to be set in the payload but it is not, so you are saying param null as the error code, and here you are in the message you are telling that this particular parameter was not set, so kindly set this and retry again. So stuff like this, right? So this is how you handle your errors and exceptions in a REST API. So in the last, now we are trying to explain how a user journey might look like on an e-commerce platform, and what all APIs a user might use for this entire its e-commerce journey, and how we will define that in our system. Okay, so a REST API, basically REST API context for a e-commerce platform. So what all a user might do in an e-commerce platform, right? So first we will define the scope of the problem. A user might want to do get of products. Okay, so after getting the product, it might want to do is add some product to its cart. Okay, so the user journey, we are trying to define that this is the scope of our problem currently. Okay, if after it add to the cart, let's say it has added multiple products, right? So what it could do, go to the order page, get my orders, or go to the checkout page. So these are the currently the orders in its list. Okay, so once you do that, after that it could be place order. Okay, and then it could be perform payment. So let's say this is the scope of our problem currently, and these are all the APIs a user might need to interact with. So what we'll do, we'll see how we'll design the REST API for this, right? So get products. So first of all, you have to have get of products. Okay. Okay, this is fine. We now have a get of product which gives us the entire list of products. Then user might click on one of the product and you might want to give the detail of that entire detail of that product, right? So it will be products slash id now. So now you give the entire details of one particular product. Okay, and it could again, then you might be using query parameters also to do some filtering or sorting and stuff like that, right? So get of products. Okay, uh, get of products, but with the sort or search, something like that. Okay, sort, whatever, something parameter you want to give. So this is what the products API will look like. After that, there will be a button to add item to the cart, right? So what can now the API for that can look like is for do the post on users, because it is a user cart. So particular user's cart. So user, then ID of the user, and this cart post, add an items to user's shopping cart. Okay, then this API user might use many times, and then it goes to the page of where the entire cart is. So get the same users, same thing, cart. Okay, so get of the cart for this particular user. Now user is seeing the entire list of its all the products in its cart, and it might want to delete something from there, right? So now you also want to define a delete API. Okay, on this users ID. Okay, cart. Now cart may say if you want to delete one item, it will have some item ID. Okay, so this is the delete API for the cart. So till now, what all APIs we have defined? We have defined the get of products API. Then in the manipulation, then after products are added to cart, the cart manipulation API also. Now we have uh, seen. After this, what could be the next thing? It could be orders. There are uh, now there are these products in the cart, and user might want to place an order for that. So one API you need for that is post of orders. Okay, for this user ID orders. So now this is the another URL which we have defined in our REST contract, post of orders. Okay, once you create this order, in this response you will get an order ID, and you might want to see that particular order, right? So get also you want to support for this orders slash order ID. Okay, so you want to support get also on that. Also, what you might want to support, get of all the orders. Okay, user might want to go to his history and want to see all the orders he has done till now. Okay, then get on to this orders till here only. User ID orders. The what we use for post, we'll exactly use the same for uh, get. And obviously this can use filters, because if he wants to see the orders only he has done in the past 2 days or 10 days or stuff like that, right? So we'll use query parameters for that. So this was our first set of APIs. Products, this was our second set of APIs. Cart, this was our third set of APIs. Manipulating the order, it has done get and place order. Now next set of API is payment. So once the post of order is done, now the user is directed to payments page. So for that you need to create a new payment. Okay, post of payments, create a new payment and process that payment. And then after that you want to track also that what happened to that payment, right? So get of payment slash ID once. So whenever you create a new payment, in the response you will get some ID, and then you can track that what has happened to this payment. Okay, so this is the API with which an e-commerce platform might have to define for in the entire user experience which it has. This is very minimal example. There is a lot more things which a lot more APIs and stuff which you might want to define. Till now we haven't defined the payloads of all these products, users, cart, and stuff like that. And there are many details. But what we have done here is we have just tried to define all the possible REST APIs as per the problem scope which we defined. And if you increase the problem scope, then the APIs which you will have to define will keep on increasing and stuff like that, right? Okay, thank you. So hello guys, I hope you liked today's content, and if you did, please do not forget to like the video and subscribe to the Talent 500 YouTube channel. In case you have any queries about the content, post down in the comment section, then we will definitely try to cater to all your queries. So have a nice day and see you again.